question 11. It says, in this diagram, the points A, B, C, and D are on the circumference of the circle center O. AOC is a straight line, so this one is a straight line. OD is parallel to BC. These lines, they're parallel, and you can also see it with these arrows. DAO, angle DAO means DAO, this angle, it's equal to 30 degrees. So you're asked to find ODB. So ODB, this angle here, that's the angle that you have to find. So here it's not really direct, and if it's not direct to you, then it's also forgivable. So what I advise you to do is to fill up as many angles as you can and do it real quick. So these are angles in the same segment, so this one should be 30 degrees as well. So you can see that the corners here, they're on the circumference. These angles, they are on the same segment. And we can also find this one. This one, it was kind of hidden. You have to be like really careful. This one was kind of hidden. When you see this, the angles formed from D and C. So you have this angle formed at the center and this angle formed at the circumference, and they're both formed from D and C. So angle formed at the center, it's equal to twice the angle formed at the circumference. So that's why here, this one, it's 60 degrees, right? And then once you have figured out here that angles in the same segment, they're equal, you get 30 here, you also have your angle here. It should be 30 degrees as well. These are called Z angles. So you have this one parallel to this one, so this angle must be equal to this angle. So these are called Z angles. So that's why this one is 30 degrees. Then you can quickly write 30 degrees. And ADB, did we compute ADB? ADB. So we want this whole angle here. We have to compute this whole angle. Well, obviously there are many methods, but then just since you computed 60 here, you can also compute this angle as well. So angles on a straight line. So this one must be 120 degrees. 180 minus 60. Then you get 120. Now since you have 120 and 30, you get 150 all in all. That means that this angle must be 30 degrees. So 180 minus 150, you get 30 degrees. Now you have 30 and you have another 30 here. So you add the two, you get what? Get 60. And then ACB, maybe we've computed already. ACB. Oh, it's this angle here. And again, angles in the same segment. So this one should be equal to this one as well. So expect to get 60 degrees here. 60 degrees here. And that's it for question 11. Let's move to question 12. Question 12, it says, in this diagram, we have this triangle and we have this circle with center O. And then OC is equal to 4 centimeters. This one, 4 centimeters. And line L is a perpendicular bisector of A and O. So this one, this is the line L. So it's the perpendicular bisector of AO. Okay, that means that it cuts in between. So now you're asked to describe the locus that the circle represents and describe the locus that the line L represents. So the perpendicular bisector, what locus does it represent? So for the circle, always the points at the circle, they are a certain distance from the center. So that's how you describe it. So you say the distance should be the radius. So you can say locus of points 4 centimeters from O. If you want, you can say from center O. So these points, they represent locus of points. They're a locus of points 4 centimeters from the center. And this perpendicular bisector, this line, what points do they represent? They represent locus of points equidistant from A and O. So if you want, you can say locus of points equidistant from point A and point O. Every time this one's a perpendicular bisector, so any point here, when you measure the distance getting back to O and getting back to O, getting back to O and getting back to A, it's always the same. So we say that this locus, it represents points equidistant from A and O. Okay, so let's move to question 12b. Okay, number 12b says P is both inside the circle and inside the triangle AOC. So inside the circle and inside this triangle. Show by shading in the diagram the region in which P lies. Okay, so the region in which P lies. So it's both inside the circle and inside the triangle. So we're dealing with this region here. Okay, we're dealing with this region here. That's inside the circle and also inside the triangle, right? And then we are told that it's nearer to A than O. Our perpendicular bisector, remember, this represents the locus of points equidistant, which means an equal distance from O and from A. Region that we want, it's nearer to A than to O. So it should be this region. This region is, this line, it's what separates the two regions. These points, they'll be nearer to O than A. These points, they'll be nearer to A than O. So this is the region that you're supposed to shade. Let's move to the next question. Next question says convert $5.40 to South African rands. You're given an exchange rate. Please don't use an exchange rate from your head that you know. Just use the exchange rate that you're given, even though sometimes it can be ridiculous or something. So just use the exchange rate that you're given. So use simple proportion. So if you want, you can even say using simple proportion. Okay, let's write using. If you want, you can say using a simple proportion. Using a simple proportion, we have $1 is to 12 rand. Then we need $5.40. This one should be more. These are directly correlated. The more money in dollars that you have, the more equivalent rand that you have. So we say more whenever we compare. There's such direct relation. So if it's more, what does it mean? It means bigger number on top. You might know this from primary school, right? Times 12 rand. If you want, you can put the dollar signs here, but then obviously they'll cancel. So what you just have to do is to multiply 540 by 12. Remember, you have two decimal places. This method is from primary school, so you expected to know it. So here 0, 4, 5, just like that, and then 2, 0, 2, 8, 2, 10. So we get 6, 4, 8, 0. Then two decimal places. Okay, let me just rub this off first. So this one was supposed to be like this, and then you'd have this, and two decimal places, it come off like this. So how much do you get? $64.80 rand. And you're done. The B part says a farmer borrowed $2,000 at a simple interest rate of 20% per annum. Calculate the amount payable after 2 years. So this is simple interest. A farmer borrowed $2,000, and we want to calculate the amount of money that will be payable, that you'd have to pay after 2 years. So I'll take this in steps. So you can say after first year. You can say after first year to clarify. Farmer pays how much? 2,000 plus 20% of the 2,000. So here, if you want, you can even say 2,000 plus 20% means 1/5. Okay. So of 2,000, like this. So here you cancel. Let me get a different pen. So here you cancel. you get 400, because 5 into 20, you get that. So all in all, you get what? 2,400. That's for the first year. So after year 2, and here we're assuming that the farmer hasn't paid anything yet. Okay. So after year 2, you get 2,400, the amount that that the farmer has, plus 20% of 2,400. So here you get 2,400 plus 1/5 multiplied by 2,400. So let me change my pen real quick again. So here you get into 24, you get 4, remember 4 into 40, you get 8. So you get 480. So you get 2,400 plus 480. This is in dollars. Then you get 2,880. So this is your answer here. Okay, this is your answer. So 2,880. That's the amount payable after 2 years. Let's move to question 14. It says in the diagram, A, B, and C are given points on level ground. Point B is 4 kilometers from point A. So point B is 4 kilometers from point A. I'm sure this part is cut. So from point A, BAC is equal to 10, this is equal to 10, this is equal to 120, and you're asked to state the bearing of B from C. So whenever you're asked to state something, it means that the answer is almost immediate, or the answer is very, very easy to find. Okay, so don't expect so much calculations when you're asked to state something. So what you do here, you need the bearing of B from C. So it says from, go and draw a cardinal north. So it says from C, that's why I'm going there to draw a cardinal north. Our bearing is taken clockwise. You take the bearing up to the line that joins to the point that you want. So from C to B. So here, so you need this bearing. That's what you want. You're told that this is on level ground. Okay. So this angle and this angle, they should be equal. So this one is 120. So this one should also be 120. It's that same case, that similar case of Z angles that time. So you should get 120 here. Then this one would be 90, because this one is on level ground. North and level ground, they make 90. So at the end of the day, you get what bearing? 120 degrees plus 90. So you get 210 degrees. Okay. So this is your bearing, 210 degrees. If you want, you can even say 210 degrees. Then you say clockwise, still okay. Let's move to question 14. It says using as much information given below as is necessary, calculate BC. So I want to calculate BC here. So how do you do this? You first just analyze your triangle. Normally when you have cosine, when you have to use cosine rule, you have two sides sandwiching a known angle. So here we only have one side. When we have a pair, a side and an angle facing each other, and we have those two, then we can use the sine rule. But then the problem here is that we don't have the angle. So how do we get the angle? This one, it's just a triangle. So 10 plus 120, you get 130. 130 from 180, you get what? You get 50 degrees. Okay. So once you get 50, now you have a pair. Side angle pair. And you just have to, what exactly do you want to calculate? You want to calculate BC. So you say using sine rule. Using sine rule. You have BC by, so BC here, this is the side that you want to calculate. The opposite is 10. So it's sine 10 degrees. You go to, then you take the pair that you have now. This is a side, so always write the side. Okay. If you start with the angles, then you can also write the angles as well. But right now we started with this side, so you also put the corresponding side here. So 50 degrees. So BC equal to, this one goes there, so you get 5 by sine 50 degrees times sine 10 degrees. Okay, so here what do you get? You get 4 by sine 50, you're already given. Okay, sine 50, where is sine 50? It's 0.8. So 0.8 like this, and multiply by sine 10. Sine 10 you're already given. What is it? 0.2. So here you get 0.8. 4 by 0.2, you get 0.8. Divide by 0.8, then you get 1. So your answer is supposed to be 1 kilometer. Okay, I'm just writing here because we don't have any space. So your answer is supposed to be 1 kilometer. First, analyze your triangle. If your triangle is not right angle triangle, Pythagoras is out of the question. Trig ratios, they're out of the question. Your triangle, it's not a right angle triangle. It means we can use either cosine rule or sine rule. Cosine rule is normally used when you have two angles, two sides sandwiching an angle. So if we had another side here, that's a hint that we are supposed to use cosine rule. Sine rule needs a corresponding side to an angle. So side angle ratio, we need that for sine rule. The trick here was that we had to create, and you created here by insisting that angles in a triangle, they add up to 180. So that's it. Let's move to the next question. Question 15. Question 15 says evaluate log base 3 1 by 243. I'm going to do the simple way first, and then I'm going to show you a very interesting way to go about it as well for those who love maths. So the simple way is to say let log base let log base 3 1 by 243 equal to x, and then this one, the base kicks the number and it becomes power, and you have 1 over 243 like this. So you have 3 to the power x equal to, this one almost always it'll be, or you should recognize that this is just 3 to the power 5. You should recognize it. 243 is 3 to the power 5. If you didn't know, just commit it to memory, just because it's very common to use 243 there. 81 is 3 to the power 4. 27, 3 to the power 3. What do we do here? Laws of indices. This one is at the bottom. When it kicks back to the top, it means that it becomes negative. So you just get x equal to -5, just like this, and you're done. Okay, so let this equal to x. The base kicks the number, becomes power, and then you push this one back, then it gets to replace like this. And you just have to make sure you make the bases the same so that the powers can also be the same. Then at the end, you just equate the powers. So for those math hobbyists, people who actually love maths, this is another way to go about solving the same problem. So equal to, use the law of logarithm, one of the laws of logarithm, by breaking this down. So you break it down this way, 243 like this, done. Then here, for any base, log 1 is equals to 0. So for any base, log 1 equals to 0. So you just say this. Then this one, you write it as 3 to the power 5, because we established that 243 is 3 to the power 5. So this one will become 5 log 3 base, log base 3. So you get here, okay, let's just ignore this. So it'll be 5 log base, when the base is the same number as the number, it means that it's always equal to 1. So you get this. Okay, so when you have log base x1, it's always equal to 0 for any value of x. Log base x is always equal to 1. So these two are the ones that we used here, and you get the same answer for those who love maths. But then if you have a hard time understanding these things, stick to the first method. It's very easy. Actually, it's the method that we're going to use here. So 81. So remember last time we said let that equal to x, just because we didn't know, we didn't have anything here. But then right now we have the same thing. Let's do the same procedure that we did without letting it equal to x. we already have a certain value here. So we said we take the base, we kick the number to become, and then we push this one over. So 81, then you get 3 to the power 2x minus 1 equal to 3 to the power 4. Then you get 2x minus 1 equal to 4 here. The thing that we need to do, in this step, we wanted to match the bases. So when you match the bases, you can always equate the power, just like in the previous example. So you get 4 plus 1, which is 5. So you get 2x equal to 5. You divide both sides by 2, then you get x equal to 5 over 2. You can leave it like this. You can write it as 2.5. That's it for question 15, and I'll join you in the next video for questions 16 to 20. Thanks for watching. Cheers.